Hello, the School of AI. My name is Sai Shetty, and this is our submission for the Capstone project of ERA-V3 course. This Capstone project is done by a team of 5 contributors: Sai Shetty, that is myself, Venkatesh Babu DB, Arghya Mukherjee, Tausif Ahmed, and Supreet Kausika. For our project, we have created a product which is an agentic AI travel planner. This product is more on the A side, the A part that Rohan had suggested, which was a heavy fine tuning and a basic agent system. So without further ado, first, this is our GitHub repo. This has been shared with you. I will walk you through how the code is and how does it work. But let's first start with a small demo. All right, so this is our AI travel planner. This is the front end. This is powered by a backend agentic AI system, which is a fast API. And as you can see, let me just give you an overview. This is an intelligent travel planner. This is a new conversation button that you can use to start up a new conversation. We have the capability of both textual and image input that can be provided. As you can see here is there are certain preferences that you can set. Let's say you want to do budget, or you want to do moderate or luxury. How do you want to put your travel style? The interest, culture, food, travelers, English, and dietary restrictions. This is the first section where you can upload an image of a location that you want to visit. Let's suppose that you have a place that you have seen on Instagram or Facebook or some other social media website, Pinterest probably, but you don't know what that place is, right? So let's try that. Uh, for example, I have this image. Now we all know that this is Bangalore. Let's see how this works. So I have uploaded the image here. Now I can click identify location. Now while this is happening, let me also show you how the backend is working. So we have 3 APIs here. We actually have 2 major APIs, and there is the one which is the agentic system itself. This is our Llama API. This is API over the Llama model, Llama 3 8 billion instruct model, which we have fine-tuned using our custom travel data set. We took the base model and we have fine-tuned it on AWS. And as you can see, this is working properly. And similarly, we have another API which is a geoclip model. So this geoclip model is being further fine-tuned on the geoclip model that is present on Hugging Face, and we are serving this also as an API. So the image that we had predicted, the image that we had given, that image goes to the geoclip API, and that gives us a prediction. So if I show you here, you can see, right? So we have correctly identified the location of this image, which is Bangalore, Vittal Malia Road, D. Souza, Sheshwan Town, Bangalore, Bangalore North, Bangalore Urban, Karnataka. So this is correct. There is some variation in terms of the exact location, but the region is coming pretty properly. Now, I have the uploaded image. Now let's suppose that I want to create an itinerary based on this. So what to do? I can ask a question like this. So let me just pose this question here. I'm interested to travel to this place with my family for a week from Mumbai. I want to explore the streets and famous tourist attractions here. Help me generate a detailed itinerary along with latest pricings on hotels and flights to and from this place and Mumbai. Departure date 20th August, return date 27th August. So my expectation is that this agent will be able to uh, create an itinerary, but not just the itinerary, but there are some additional things that it will do. Let me just hit get suggestions here, and then we will see. So as you can see, this is generating an agent. So now, while we are here, let me just show you the agentic side. As you can see, a new agent executor chain is started. The agent is a LangChain agent, which has access to specific tools. So as you can see, there are 4 tools that I have added. We have added to this. There's a flight search tool, there's a hotel search tool, there's a weather tool, and itinerary planner tool. And this, the backbone or the main LLM engine of this, is our Llama API. The reason I'm doing this, so this is a local version of this. I'll also show you, we have uploaded this code base on, we have hosted this code base on AWS as well. The reason I'm showing this to you locally first is that I wanted you to go through and wanted to see the logs of how the user request is getting processed. As you can see, our Llama API is called here with tool calling. And if I come here, so this just takes some time because it is running locally on my PC, but I'll also show you the AWS hosted version. So as you can see, we are in the new executor chain. My request that I had given, I want to travel to Bangalore I'm interested to travel to this place with my family for a weekend from work. So entire user query along with the location information and other details about the context is passed to our model. Now it does take some time, but we are waiting for this. Meanwhile, like as you can see, the image that we had passed to the GeoClip API, it was able to successfully generate a prediction. So now we're in the executed chain. Here, meanwhile, our Llama API is being called. I can show you the memory that it is consuming. As you can see, it is using around 8%. Now, as you can see, we have some response here. Now, our agent has successfully calling the 4 tools that we have given. The hotel search tool, the flight search tool, the itinerary planner tool, and the weather tool. Now, its job is to call these tools, get the responses, and use that response to generate the itinerary. So as we can see that this is the functional tool calling is happening exclusively from our Llama model, which is running locally right now. So that is a big achievement for us. That was our priority, that we are able to show agentic capability, functional calling using our custom model and not let's say Gemini or any open source or any paid API. So we have been able to show that capability. Now, as you can see, we have now it's basically calling all the tools. So it is planning the itinerary, right? So it's planned the itinerary. Now it is calling for the flights. It found 3 flights. Now it is searching for hotels in that location. So I'll also show you how the tool calling is happening. What are the exact functions? There are 4 hotels that it has found, and it has also got the weather for Bangalore. Now it is again calling our Llama API. So let me just show it here. In this API, now it is basically summarizing the entire tool response and everything that was provided, and it is using that to create the final itinerary. And also, just an addition, along with the local Llama API, we also have an Open Router API with the same model, the Llama 3.18 billion instruct model, as a fallback. So in case, let's say on AWS also, if our Llama API is failing, if the requests are not going, if any issue comes up, then the agent will direct the request to the Open Router API instead. Now, let's wait for this run to get completed. Meanwhile, there is the generating travel suggestions is happening. So let's wait for the final output to be shown. As you can see, I have mentioned the departure date and return date as well. Just to show once again, as we can see here, it did correctly find that it wanted to search flights from Mumbai to Bangalore on excuse me, on 20th of August 2025, exactly the date that I had mentioned in the query. So it was able to do the NER, it was able to extract the date, it was able to pass that properly to the API, and it also found a successful response. So my hope is that this part will also work. Now, let's just wait for this to be done. As you can see, the API is still running the prediction. It has got the response and it is working its magic. All right. So we finally have a response. Let's see on the front end. So travel recommendation for the location that we had shared. We recommend the following flights for your travel. So as you can see, it has found not just the itinerary, but it is also giving us the flight numbers that it should take. And just to prove that these are the actual flights that are there, let's just copy this. I'll just open up Google. And as you can see, this is the exact flight that it had fetched. 3:15 to 5:15 Mumbai to Bangalore on 20th August, and it has also given us the price. So this is something that will help the user to plan its travel. As you can see, this is the exact flight details that we have. Similarly, if I check this one, again, a correct flight. This one is also showing 9:50 a.m. to 12 p.m. as it is correctly there. So we have the exact flights, the correct flights which are present. At the same time, we also have hotel options that we are providing. As you can see, there's a Ramanashri Lachman Hotel. There's Ibis Bangalore City Center. There is New Rainbow. It is also showing the weather, what weather it is there. So these are the information, the critical information that is required for a person to plan out his or her trip, and all these details are shown, and this is something that was formatted and fetched by our llama model. This was not a Gemini or a open router API that was doing that. This was our llama model. As I'll show you here in the llama API. It was able to return the chat request completely successfully, so that did work. Now, if we talk about a travel plan, as you can see, it is given the proper plan also. It's saying to morning to visit the Lal Bagh Botanical Garden, lunch at Vidyarthi Bhavan, dinner at Koshi. So it is also referring to the local restaurants which are out there. It is asking a second day, it's saying visit Bangalore Palace, visit National Gallery of Modern Art, cultural show at Rangashankara, and there are other days that it has mentioned. Um, yeah. So this is the itinerary. Of course, there is some confusion happening. As you know, this is a llama model, so we have to acknowledge that there is some confusion that happens. Also, I'm running this on a local machine with a quantized version, 4-bit quantized version, but that is why there is some confusion that happens. But this is itself, this is the AI travel planner which can run locally. I have shown you the logs. Now let's do one thing. Let's see the one that is deployed on AWS. All right. So let me just copy this. This is my query that I will put to AWS. So here, right here, this is our AI travel planner that we have deployed on AWS. The three APIs that I showed, the three services that I showed, we have Dockerized this and deployed it in the Amazon Elastic Compute Service. So there are three Docker containers, one containing the Llama API that we have, second containing the GeoClip model, and the third containing the agent, which has both the front end and the back end. And to give you an overview of how this is interacting, let me show you in our GitHub README. This is present. This is our code execution flow. This is where the user uploads an image and a query. This image is given to a GeoClip API that gives us the location info. The text query along with the location info is given to an Agentic AI frontend that we just saw. From here, the Llama API is used to get the request and the response. This response, if contains the tool calls that we just saw, this goes to our flight, weather, hotel, and itinerary tools. From here, the data is fetched back. This data is passed back to the Llama API, and the Llama API, taking all the responses, all the tool responses, and the original user query, finally prepares the itinerary and passes it to the user. So this is in the nutshell how our uh, Agentic AI Travel Planner works. This is a flowchart. This is present in our GitHub README. And in our AWS version, if I show you here, this works completely same. This also has those three Docker containers that I just told you working in the backend. They are hosted on ECS. So let's try one thing. Let's present our ideal trip. This time I want to travel to Delhi from Mumbai in January 2026 to see Republic Day celebrations. Help me generate a detailed itinerary for a week. Now this time, because we are mentioning both the location, destination, and the origin. If you remember, in the first one, we did not mention where you were going. As you can see, we did not mention Bangalore at all. It was able to detect that from the identified location. Here, I'm mentioning Delhi, and I'm also giving the dates from 20 to 27 January. So let's see what the suggestions come up. So this currently is hosted on AWS, and that's why we cannot see the logs, but it will work much faster than the local version, because the local version is hosted on my local system, so it will take time to make the predictions. But in the AWS, that it will not take much time. So let me show you. Let's work with that. With our, yes, so as you can see, this has also worked, and we also have everything. We have the flight options that is given. As you saw, the inference time is much faster on the AWS, and as you can see, the flight options we have got, which is the 6E6028. Just to confirm once, these are the accurate flight prices. As you can see, this is the correct. It's Bombay to Delhi at 12:30. That is departing, and here there is a slight difference, but that is okay. We have the three hotels also. We have the Leena International, New Delhi, and just to confirm that this is an actual hotel, I'll just search it on Google. As you can see, this is an actual hotel in Delhi, so it has given the proper hotel options also. And mind you, again, here also everything was done using the Llama API, the function calling, the hotel data, everything was formatted by our Llama model, which we have fine-tuned. And it has given all these hotel options, it's giving the weather also, has given the itinerary also. In this itinerary, as you can see, because here the Llama model is loaded on full precision in a GPU, which is why our expectation, and as it is being shown, that it is working much better in terms of the responses. And with, as you can see, uh, there is no hallucinations that are happening, which were happening in the local version. But this gives you an idea that this was deployed properly and the functionalities are working. Just to give you an idea if the images are working, let me just put this image. This is the skyline of Fuji, and I'll just identify a location out of this. Now let's see how this works. This is on the AWS ECS where we have deployed. As you can see, it has correctly predicted that Yamanashi Prefecture, which is the prefecture of the Fuji Mountains in Japan. So the GeoClip API is also working. So all the functionalities are working on the AWS ECS as well. We also have another mode. So this is the mode where we have proper. So I'll show you one more thing. So this was the conversation mode. We also have a detailed itinerary mode. So what happens detailed itinerary? Let me just do a new conversation. Let me come to detailed, one second. Yeah, to a detailed itinerary. Here, instead of putting the full text, we can just pick locations like this. So if I do, let's suppose Paris to New York, let's do Mumbai to New York, because I am a Mumbaiker and I like my country. I like my city. But yeah, we'll do Mumbai to New York, USA. I want to go in the October 1st, all right? And I want to go for, let's say, 10 days, right? So let's see how the itinerary works. So this is a second mode that the user can use, and this is where it can basically put in the details like as a form, and that information will be used to prepare the itinerary. I can remove this because the image is irrelevant here. One second, there must be some issue. One second, let me just load it again. Right, so we have a detailed itinerary. I am putting Mumbai to New York, USA for 10 days. Let's do 20 days for October the 1st. Right, so Mumbai to New York, USA, 20 days, October the 1st. I want to go. Let's create an itinerary for that, and let's see how that works. All right, so unfortunately did not get the oh, my bad. I had picked actually New York to Mumbai. That is the origin city and the destination. It did not get the flight options, unfortunately, but it did get the hotel options, and it will give a itinerary based on the context. As you can see, it has given a quite brief itinerary. Day 2 to 20 is done, but day 21. Of course, there's some confusion that is there with the model. That is understandable, but definitely it has done a good job in terms of the hotels and the. I know that there's a Google Home, Big KC Suite, Lehman Peter. Let's do one thing. Let's just reverse this out. So for me, my 1 second. Yeah, I'll have to start a new conversation. Yeah, this time I'm going to New York and my Mumbai will be the origin, and this time we'll do only a bit too close. Yeah, a 7-day itinerary from Mumbai to New York. And let's see how this works. All right. So we have some flight options that are not present, but we have the New York hotels that are present, and at the same time we have the weather, and we have a proper itinerary for all day, all the 7 days. As you can see, it is arriving at the airport, visiting the iconic landmarks at the Statue of Liberty, Central Park, Empire State Building. Take a break from sightseeing, explore the city's many attractions. As you can see, the 9/11 Memorial and Museum. Enjoy a Broadway show. So it has given a proper itinerary for that. Now, I want to show another feature that we have in this. So here it's essentially like a chat interface now, where we can ask more things about it. So let's say how to go and visit the let's say Washington DC. How to go and visit Washington DC. Add that to the plan. All right, how to go and visit Washington DC, add that to the plan. So here I'm asking actually a follower. So as you can see, this is an initial image, initial message that we had sent. Create a data ID for a trip from Mumbai to New York, start date this, end date this. As you can see, this is the exact text that had gone to the LLM. Our AI agent or our travel agent did acknowledge this and gave an itinerary. Now, the second question that I asked, how to go and visit Washington DC, add that to the plan. Uh, so here there has been some confusion that has happened, unfortunately, but it has considered the, I think AA123 is not the exact flight, but it's okay. It has given the Hotel Hyatt Regency Washington DC. It is asked to arrive at Washington DC, explore Washington DC. So as you can see, the entire plan is now modified to consider Washington DC as well, and it has incorporated that and is giving the response. So there's a weather update and everything is working. So, this is in a nutshell our project. Just to give you an idea of the kind of research and development went into making this. We actually have done all the requirements of the project. So we had a base LLM which we had trained, a 1.3 billion parameter LLM from scratch. It's a small LM, and actually we have that model also here. This is a small LM2 Cosmopedia chat. This also works well. This is already deployed on Hugging Face and shared with you. We also have fine-tuned an Llama model, uh, which is the backbone of our agent. So Llama 3.1 8 billion model, which was fine-tuned and it's served as an API. We have the GeoClip API also, which is the GeoClip model with the accept images and predicts geolocation with confidence scores. That also is served as a REST API. And the last is the Agentic AI backend full stack application that we have, which has all these tools. All the information is there in the GitHub README. We are very, very fortunate to have worked on this project, and we are very, very happy that we have been able to complete it within the timelines. Just to show the contributors, I will just show in a nutshell. These are all the contributors. Everyone has worked together on this, and I personally am very, very happy to have worked with all these gentlemen, and we have been able to create this product for our Capstone project. If there are any questions, I would appreciate, Ron sir, if you can revert back to us. We will share this URL. We will keep it running for some time. The AI Trial Planner on AWS. I really highly encourage you to have a look at it. But yes, so this was the AI Travel Planner. Just a quick information on the APIs that we use. So our tools are using the rapid API endpoints. If I show here in the tools, so we have the four tools that we had shown, right? It's a flight search. There is the hotel search. So all of them are using a rapid API key. There are rapid API endpoints. It sends a request to that based on the information that we had the function is called with. So in our case, as you can see in local version, there was the call that happened using the flight search tool, the hotel search tool, the weather tool, and it was providing the location appropriately with Bangalore as the location. In the case of flight search tool, it was using the origin Mumbai and destination as Bangalore. And there are validations that are there to make sure that the proper city name is selected, and we had added that as well. It's all running in asynchronous format. As you can see, the object that is returned is a coroutine object, and same goes for both Llama models and the GeoClip API as well. Apart from that, we have the Docker files for all the three projects. So as you can see, these are all the Docker files. These were used to deploy the models, deploy the APIs on AWS. This is the Docker file for Llama fine tuning. And we are using as a fallback the OpenRouter API, but as you saw that we did not need to use it for any scenario in our local running, as I can show you here. The Llama API was used both times. So we have the Llama API available that was running. And afterwards, at the end, when we had to summarize the output, it was working. So intermediate steps 4, called with inputs, and this is the final output. As you can see, it's a very big object, but very big text, but our model was able to read it. So, right. So this was our Capstone project. Thank you so much for this opportunity. We really appreciate it. Goodbye.